Hi ladies, it's Mr. O'Sullivan. Today we're going to be learning about how to evaluate functions in various forms. Today's learning target is I can apply my knowledge of functions to evaluate them in various forms. So before we even begin, the first thing I want to make sure we need to make sure we are buying graph paper, because in our next portion of this unit we're going to be doing a lot of graphing. Right? You don't have a Delta Math for today's assignment, you just have this edPuzzle assignment, because I'm embedding your classwork basically throughout. So question number 1, we're being given this relation, v of b. We read this, not v parenthesis b, we read this as v of b. And it's basically just saying v of x, v of whatever, and yada yada yada. So the first thing we want to ask ourselves, is this a relation of function? Well, we know these are our x values. These are our y values. We know that in a function, the x values cannot repeat. They cannot repeat. So x can't repeat. So if I look at my visual, I only have one arrow coming out of -2, I only have one arrow coming out of 2, and I only have one arrow coming out of 0. So yes, this is a function. And how we know? No x values repeat. When we don't have a graph, we can actually list out our domain. So we know our domain is our what value? It's our x value. And our range is our y. So our domain for this would simply just be the list of our x values. So I have a -2, a 2, and a 0. That's my domain. You just list them out. My range are the numbers in my y that are used. So if you look, the only numbers I'm using in y are 1 and 8. So my range would just be 1 and 8. That's your range. Now it says evaluate v of 2. So I go to the number 2, start at 2, draw my arrow, and boom, I get 1. So v of 2 is 1. Try to do v of -2 by yourself. Yep, I get 1 as well. Now for our next question, it says for what values of b does v of b equal 8? So for instance, these are really our b values, and this is v of b, or our y values. So if I look, I have my 8 here, and what I want to do is go backwards. I go backwards, and I hit my 0. That's your final answer. Those are my favorite ones. Those are relations, and they're mappings. So now I'm given a series of ordered pairs. Remember, when I'm given a series of ordered pairs, these are my x values, so I'm going to put them in. So x, 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 x. These are my y values, y, 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 y. Please remember, ordered pairs are written as x, comma, y. This is how they are. So in this first example, it says, is the relation a function? Well, remember, a function, the x values do not repeat. So let's just read our x values. Our x values are 0, 1/2, 1.1, and 4. This is a function. So we'll just say yes. And the reason is, no x values repeat. My domain, so this is where we list out our x values, because remember, domain is our x. Range is our y. So we list out our x values, and our x values are the ones that are underlined in green, so the 0, the 1/2, the 1.1, and the 4, and we just write those out in a fancy set notation. So 0, 1/2, 1.1, and 4. Your range is your y values. I'll underline those in yellow. 1.1, 8, 8, and 1/2. You don't need to write the 8 twice because it's just annoying. Don't write the same thing twice. So we're just going to rewrite our range now as -1.1, -1.1, 8, and 1/2. That is your range of this function. Now, we want to evaluate d of 4. So what that means is my x value is 4, so I want to find out what my y value is. So if I want to plug in 4, I go to my 4, and I get a 1/2. Try to do d of 0 by yourself. Yep, I get negative 1.1. And that's your final answer. And last but not least, for what values of b does d of t equal 8? So basically, you need to go, we know y is equal to 8. So we go to our visual, y is equal to 8 here, and y is equal to 8 here. We want those x values, so our x values are 1/2 and 1.1. And that's your final answer. So with this image, I have a graph now. The graph of y equals h of x is given to the right. In our first question, we want to find h of negative 3. Remember, the number inside your parentheses is always a x value. So this is an x, this is an x, and so forth. This is a y, and so forth. So in h of negative 3, I go to my visual, which is right here. And the first thing I do is I need to find negative 3. Negative 3 is right there. Right here. So I want to find the y value. So I go up, 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 and when I hit my graph, I stop, I go over, and it's 3. So I can say h of negative 3 is 3. And that's your final answer. Now let's do h of 4. So I go over to 4. I'm going to erase my negative 3, go out to 4. So with h of 4, I circle my 4, and I go up, but here's the issue. I hit a bullet hole. Whenever I have a bullet hole, it means it's undefined. So h of 4 is actually undefined. And what we're basically saying is that h of 4 does not exist at that point. Try to do h of 3 by yourself. H of 3 by yourself. When plugging in 3, you should have gotten 4. Now let's find out the values of x, for which h of x is 3. So basically, here's how I do these questions. I know that y has to be equal to 3. So what I'm going to do is I'm basically going to go to my 3, my y value, and draw a line across. And if I look, I hit my graph right here. And here. I now need to know what those x values are. Well, the x value is negative 3, and the x value is 2. That is your final answer, 2 and negative 3. So what this is saying is that I can plug in 2 different x values and get the exact same y value, which is totally fine in a function. Our next example is for what values of x is h of x equal to 2. So we do the exact same procedure. We zoom in at the 2, and our 2 actually gets hit quite often. It gets hit right here. Let me do it in black. Here, 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 and here. Those x values are negative 2, negative 1, 0, and 1. So I can just write out negative 2, negative 1, 0, and 1. And that's your final answer. Your domain. Your domain is your x values. Your range is your y. So my x values, I need to ask myself, how far to the left do I go? Well, if I look, I go only to a negative 4. And how far to the right? I go only to a 4. But here's the issue. They're both bullet holes, or open circles. So I'd write this as negative 4 to 4. Or negative 4 less than x less than 4. Now, what is the range of h? The range of h is simply how low to how high, and that's your y values. And if you look, your range would be, your lowest y value is a 2, and your highest is a 5. The 2 is a closed circle because it's a solid line. So I would do bracket 2, and my highest is a 5, but that's an open circle, so it's a parenthesis. I can also write this as 2 is less than or equal to y, which is less than 5. And that's your final answer. For these, I like these the most. So with this example, you simply just plug in your x value. These are your x values. So everywhere you see an x, you're simply just going to substitute that number. Please use substitute, not just that put there. So I'm saying that x is 4. So everywhere I see a 4, everywhere I see an x, I'm going to put a 4. So I can say f of 4 is 4 plus 6 over 4 minus 2. You can type that right into your calculator. So look, I'm just plugging in a 4 for x and a 4 for x. So 4 plus 6 is 10. 4 minus 2 is 2. 10 divided by 2 is 5. That's what f of 4 is. Try to plug in negative 6 by yourself. If you did that correctly, you should have done f of negative 6. Everywhere I see an x, I plug in a negative 6. And whenever I plug in, I always wrap my number in parentheses. So negative 6 plus 6 over negative 6 minus 2. Now, negative 6 plus 6 is 0. Negative 6 minus 2 is negative 8. 0 divided by anything is 0. So you get 0. Ooh, for what values of x does f of x equal negative 1? So here's what we're going to do. For this example, it says for what values of x does f of x equal negative 1? So what I want you to do is basically rewrite that equation, f of x equals x plus 6 over x minus 2, and you're just going to put a negative 1 right here, like that f of x doesn't even exist. So what I'm really doing is negative 1 over 1 equals x plus 6 over x minus 2. And here's what we do now. The reason why I did negative 1 over 1 is so I can cross multiply. I'm now going to cross multiply. 1 times x plus 6, negative 1 times x minus 2. So I have 1 times x plus 6 equals negative 1 times x minus 2. I distribute. 1 times x is x, 1 times 6 is 6. I distribute negative 1. Negative 1 times x is negative x, negative 1x. Negative 1 times a negative 2 is a positive 2. I now need to get my x's on one side, so I add 1x, add 1x. I get 2x plus 6 equals 2. I now subtract 6, So I get 2x equals negative 4, and then my final step is to divide. So I'm going to divide both sides by 2. So I get x equals negative 2. And that's your final answer. So what it's basically saying is I can plug in negative 2 to my function and get negative 1 as my y value. These are much quicker tables, so remember, these are your x values. These are your y values. This is just a fancy way of saying y. X. So in our first example, I want to plug in 4. So I go to my table of values and I go to 4, and I look, my y value is 2. That's your final answer. Try to do f of 9 by yourself. If you do f of 9, you plug in 9, and boom, you get 3. And then last but not least, for what values of x does f of x equal 4? So we go to our table. F of x equals 4 right here. I go backwards. It's basically saying I plug in 16 to get 4. And that's your final answer. If you have any questions, please email myself, Ms. Townsend, or Ms. Jimenez. Have a great day, ladies.